Hello, Yawning Angel back again with another AMOS video. Yes, and in this video I'm going to be looking at reading a text file into an AMOS program. And before you say anything, yes, I have covered this before, but this video will be slightly different because the text file in question is a comma-separated values file. So it was back in October 2022 I originally did a video covering this subject. There'll be a link up here to that video. But that was a very simple process. Create a text file, read the values in via an AMOS program. Quite straightforward. But this time we're going to create a text file and have all the values within that file separated by commas. We're then going to write an AMOS program which will detect where those commas are and pull out each value independently and display it back to the screen. We'll do that the manual way, and then we'll do an automated way to have AMOS automatically detect where those commas are and automatically separate out those field values. And then we're going to culminate this video in taking a CSV file created either under your Windows machine or under your Mac, and then bring that into the AMOS program and have that program dynamically read through that file and pull out those comma-separated values that way. It's going to be a lot of fun. So let's grab a cup of tea and crack on into the code. So here we are in Workbench, and this is the text file I have created with some words in it. All these words are separated by commas, as you can see here, just random words or strings even. Got spaces in between them, capital letters, lowercase. Everything is separated here by a comma. So what we're going to do is, with this file, test text file 1, this is the CSV file we're going to read in to our AMOS program. I've just used TextEdit on the Amiga to create this and save this file out into the same directory as my AMOS program. So let's get this into that program. Right, here we are. Quick mouthful of tea, that's all good. Good way to start the day. Okay, so here is the start of a program which I'm going to use to read in that CSV file which I created in Workbench. So there it is there, test text file 1. And I've created a bit of a shell of a program because you don't want to see me typing absolutely everything from scratch. And as I said, I have covered this subject before. So obviously the link to that video was back further on. Take a look at it, or it's linked in the description down below. So what am I doing here? So I'm doing my screen setup first of all. Really basic screen, all the usual screen estate stuff I've done here. I then tell AMOS to open a random access file 1. This will be the first file that we're opening. It's going to be the only file, but it's number 1, and that is test text file 1. This file needs to be in the same folder as this AMOS program. Otherwise, you will need to put a complete path in here to tell the program where to find the file. Then what I'm going to do, because this is a program in 2 parts really, so I thought I'd put a bit of a selection screen on. And what we're going to do is we're going to have a basic way of doing this, and then we're going to have a more advanced way of doing this. And I just wanted a way that we could select that within the program, something quick and straightforward. So I just throw some options up on the screen and I ask the end user to choose what they want to do. And I've just got a while statement here that detects whether they've selected option 1 or option 2. It's got an input command in here, so this while statement just loops around that input statement until somebody has selected option 1 or option 2. Excuse me. And then depending on what they select, we'll fire into a different procedure. There's a procedure called simple read, and there's a procedure called advanced strings. And what I can do, I can run this as I've got it at the moment. So it's a case of select what you want to do. Basic file read and display is option 1. Advanced text manipulation is 2. And if you select something, there you go. It's not going to do anything because there's no code there to do anything with. So let's dive into simple read then and see what we need to do. Let me just double check that I've got my, open random is there. Good. Okay. So the simple read procedure is literally just going to do that. It's going to read the record from that file, and it's going to split, it's going to bring in those fields that we have in test text file 1. So what I'm going to do then is, let's see, rem define individual fields, all 6 of them for the read. Okay, and what I'm going to do is define field 1. Okay, so it's this is from file 1 because we opened file 1. So the fields within file 1, the first one is going to be 3 long as string $1. The second one will be 10 characters long, string $2. You're probably thinking, whoa, Yawning Angel, jumping ahead here, what's going on? Well, let me explain. What we're doing is defining field 1, fields from file 1. So the first string is going to be 3 characters long, the second string is going to be 10 characters long. And as you see, I've got lowercase and uppercase there. Doesn't really matter because AMOS will make them all uppercase when I hit return. The third string will be 18 as string $3. If we want to double check these, let me just flick back to this text file here. So let me show you. So the first field is going to be 3 characters long, 1, 2, 3. The second one is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 characters long. The third one will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 characters long. The fourth one will be 1, 2, 3, 4, 5 characters long. So let's quickly do that now. And some of you are probably thinking this might not be right, but bear with me. So 18 is that, so 5 as string $4. The next one will be 6 string $5, and the last one, which is happy fish, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 characters long. 10 characters long for happy fish. So let's quickly flick back, and then we'll have 10 as string $6. So I press enter, and as you can see, AMOS has capitalized all those field values. So what we've done, we've opened the file. We've now defined all of the fields that we're going to bring in off of that first record. Okay. So let's rem get the actual record, and the get statement from the AMOS manual is here from random access file get. So get the channel, which will be 1 because we've opened file 1, and the record number, which will be 1 because we're doing a random access file. And we can have multiple records in there, but we've only got 1, so we're just going to get 1. So it's a get channel 1, record 1. That's really all there is to it. So let's F3 and tidy that code up. Right. Next, we're going to print out those values. We have read from the record. Plenty of you now probably screaming at the screen going, but Yawning Angel, that's not going to work. And you know something? It might not work. And this is part of what I want to show you why we're doing what we're doing. So this way is going to show you a slight flaw in our plan. So really all I'm going to do is print string $1, print string $2, print string $3, print string $4, string $5, print string $6. Tidy those up, and off the back of that we'll chuck in a wait key command just so we can appreciate what is on the screen before going any further. So let's recap what we've done then very quickly. We have opened our random access file, which is the first file. It's called test text file. So we've opened it, and then what we've done, if we're looking at the simple read procedure, we have defined all the fields for that file. So all those fields are defined, and they're going to load into these values called string $1, string $2, string $3. We're then going to get the actual record, get channel 1 and the first record in there, and then we're just going to print those values straight out because we've defined them up here. Let's see what they look like. So let me save that program. Don't forget, you'll be able to download the code for this program from my website. So let's run this. So oh, look at that. Look at all of that. That is clearly not right, is it? And some of you out there probably know why this isn't right, but let's go through and understand what the problem is here. Right, quick mouthful of tea. And let me explain what's gone wrong here. So, in the program code, I defined the length of these fields, the values that were coming in from the first record. I split these out into string 1, string 2, string 3, but I used the actual length of the text in between the commas. So the first one worked well because position 1, 2, 3, that's fine. So that 3 characters long gives us dog, which is okay. Then I ignored the comma, which is actually position 4. Which would be 4. And then I started off here. So then I would have gone 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For my holiday. But in actual fact, what the program code is doing, it's reading, it's reading first 3 characters, and then it's going to read the next 10. So it's going to go 1, 2, 3, and then the next 10 characters will be up to 4, 5, 6, 7, 8, 9, 10, up to 13, etc. It's just reading straight through and not seeing the commas. So it's including the commas as part of those values. So let's take a look at that. So if I go 1, 2, 3, that's fine. Now I go 10. So the next character after 3 is 4, which includes the commas. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which takes me to there, which is missed off the Y off of holiday. And then the next one is 18 characters for string 3. So 18, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Cut off the last 2 letters of the word George, etc., etc. So you can see what's happening there. The program is not aware of the commas at all, so it's including them in my field length definitions. So what I need to do then is work this out. We need to look for those commas and only take the values between the commas. So this is how we're going to do it. What we need to do is read in that whole record as one long string. Okay, this is quite important. So rem get the record again after defining one long string to put the record in to. So what we're going to now do is field 1 will now be 58 characters long, and we're going to call this base string $. 58 characters long. That's the whole length of that string. Okay, and I can prove it. So let's go in and count that. We know, so if we look up here, the column number, so 58 is that last one, okay? Drops into 59 is right at the end. So this is actually 58 characters long. This whole string here, 58 characters long. Brilliant. So we've defined field 1 now as 58 characters long for base string, okay? And what we need to do is get it again. So we need to go back to the file and read that in now to this new definition. So it's going to go back and do get 1, 1. We've got that, that's okay. And now what I'm going to do is print the base string from the file, and we'll do a very quick locate, comma 15, print complete string from file record, and we'll do locate, comma 16, we'll do pen for, change the color of the ink there, print base string $, and then switch the pen back to that color. Right, so what we're doing here, you're probably thinking, well, hang on, you've only used, what's going on with your locate statements? I'll explain. If you ignore the first parameter, don't forget locate is X and Y, so I don't want to print any further across the screen. I just need that to be at its, at 0. So why bother putting 0? All I need to do is actually tell it I need to print on the 15th line down and this one on the 16th line down. So you can just ignore the first parameter, just do comma and then your Y coordinate. Quite straightforward. So we'll print that to the screen. Then we'll do another wait key because I want to take you through this a step at a time. So let's save that. And let's run this program now. So that's our first definition. That's what we started with. Now, let's bring in the complete string from that file record. And that's what the whole string looks like, okay? That is what base string consists of. Happy? Good. So now what we need to do is start to separate this out. And this is where the magic starts to happen. So I'm going to introduce you to some new instructions now, and this is going to get really exciting. This is where the string manipulation starts to come alive. So first thing we're going to do is locate, comma 19, and rem. Now start to separate the string out. And what I'm going to do now, I'm going to start using string 1, string 2, string 3, because I want all those values from base string into individual strings. And this is how I'm going to do it. So string $1, yep, is now going to equal, and here's our first new command for manipulating strings, and this is left $, or left string, okay? What left string does, it returns the leftmost characters of a longer string. So if you have the AMOS Pro manual, this is on page 050201 for left string. So left string's syntax is basically take a string from, we're going to take this from base string $, and I'm going to take the leftmost characters, but the first 3, and that's what that is going to be. And then I'm just going to print that out, string 1. Okay, I'm going to chuck another wait key in here, so I love my wait key commands. Right, so left string is going to look at base string and take the first 3 characters. Right, this is really straightforward. And it's going to take those 3 characters and it's going to put them into the field string $1. And then we're just going to print string $1 out. So let's run this program. That's that. And there we go. So there's our first word is now come out, dog. Happy days. Now we're going to get a little bit more advanced because you're thinking, well, that's all well and good, Yawning Angel, but how do we deal with these commas? And this is what we're going to do. So I'm going to set a value called comma, and comma is going to hold a numeric value. It's going to hold a numeric value of where the first comma appears. I mean, you can call this anything. This is just a variable name. It doesn't matter. I've just elected to call it comma. Then we're going to use a command called Instr, I-N-S-T-R. This is on page 050202 of the AMOS Pro manual. And what this does, it searches for occurrences of a given string within another string, right? So I can tell Instr to go and look for a comma in base string, and that's what I'm going to do now. So Instr base string $, comma. So you tell it the name of the string you're going to look in, and then you tell it what you're actually looking for. And I am looking for a comma. You've got to put that in quotes because it's a string value, okay? Single quotes. And then you need to tell it, bear with me, its start position. Where is it going to start searching from? So I'm going to tell it to start searching from position 0, right at the start of the string, okay? And then I'm going to set my second string to equal, and you're thinking, oh yeah, left string. No, we're using another command now. I hope you're making notes. We're going to use mid-string. So mid-string returns a number of characters from the middle of a string. Can you see where this is going? And mid-string's parameters are as follows. We need the base string, if I spell that right, base string $. So that's the string we're looking in, okay? And then we're going to use the position of where it found the first comma, okay? I'm going to add 1 to this, and I'll explain why in a minute. And then I'm going to take out a set number of characters, and I know that my second string is 10 characters long. Yep, and then I'm going to print, I spelt that wrong, let's do that, print string $2. Right, and let's do this. Okay, so let me explain this in a little bit more detail. So what I'm doing with the comma here, Instr is going to look in base string for an actual comma, and it's going to start at position 0. And where it finds that value, it's going to return that position to this variable we're calling comma. I could call it anything, yeah, value, number, whatever. It's storing that value in there. Then I'm going to use mid-string to strip out my second string. And that's going to go and look in base string. It's going to go to the position where comma is, but I don't want to include that comma, so I need to move it up 1 more position, and then I want to take out 10 characters. So that will then put that string value into string $2. Let's run this and see what happens. So that's that. So now let me do, there we go. Whoops, let's run that again. A little bit too quick on the keyboard there, Yawning Angel. And it's done that. It's stripped that out perfectly, and I don't have any commas. Look at that. So let's just dive back in and have a look at that, because I think this mid-string might need a bit more explaining. So mid-string is looking in base string. So in this instance, it's going to look for where the first comma is, and I know the first comma is at position 4. Let's prove that. So 1, 2, 3, 4. That's where my first comma is. So I want to tell it, so go to where that first comma is at position 4, and then increment 1 space across, and from there take 10 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to get me that string. Happy days. With that done, now we can use mid-string, a combination of mid-string and Instr all the way through to pull out all the other values. So let's go and do that again now for the next one. So comma equals instr, base string, and all I need to do now is comma, quote, comma, quote, comma. And now I need to start looking in a different place. I can't start at position 0 because I've already found the first comma. Now I need to start from where that first comma was and move forward. So this time round, I'm going to use comma +1 to search for my first comma. My second comma, sorry. This will search for the second comma. So now I know that string $3 will equal mid string from base string, yeah, comma +1, comma, and I know my third string should be 18 characters long. Okay. Type mismatch error, comma equal in string, a base string, string. There we go. And I've still got another one, mid string, base string, string. This is what happens when you're trying to think and type at the same time. There we go. So what's happening here? Right. So we've got string 1. We've got string 2. Now I need to start my search again for the next comma. So instring needs to start at a new position. And I know that my first comma from this first use of instring was at position 4. So I need to go to position 4 and go forward one, because if I tell it, well, start at position 4, it'll go, well, there's a comma here at position 4. Yeah, I know that. I need to know where the next comma is. So I need to push it forward another space or another character so it starts its search there. That's why the comma +1. And this is why when I go to pull out mid-string, the new value of comma, I need to go forward one more character to then start my 18 character extraction to get string 3. Save that, run it. And here we go. So you can see this is all starting to come together quite nicely now. I'm beginning to extract these values cleanly because I'm looking for the comma, positioning my cursor one space after the comma, doing my extraction, and then moving on. Some of you might be thinking, there's got to be a quicker way to do this. Well, there is, and let me just finish off pulling out the rest of these strings and we'll come back and then take a look at a more automated way of doing this. Right, I have added in the code for string 4, string 5 and string 6. You're probably thinking this looks remarkably similar to the previous code using Angel, and you'd be right. And hold that thought because we're going to be doing something with this for the next part of this program. But literally all I'm doing is each time going through, well, where's the next comma in base string? From there, use the mid string or the mid dollar command to strip out my actual string because I know how long that is. So string 4 is 5 characters long, string 6 is, string 5, sorry, is, string 4 is 5 characters, string 5 is 6 characters, and string 6 is 10 characters. Let's run this program and see what happens. So that's my old broken way. That's what the whole string, all 58 characters looks like. And now I've stripped them all out. And as you can see, I've got all of these values. They're all there, they've all come out nicely, they're all clean, they're not clipped off at all the commas have been dealt with, it all looks quite good. So there's a lot of code here to do a very simple thing, and we can probably automate this process because sometimes you're not going to know how long your strings are, and you just want your AMOS program to dynamically go through and extract the values between the commas. So let's get on and do that next. Okay, so here we are in advanced strings procedure, and I've defined my field 1, 58 characters as base string. I've done that again. I've then got the first record, so we've defined our field that we're going to load all 58 characters into. We then go and get the record, and then I'm going to define some variables, and I'll explain these as I go on. So found at 1 is going to be 0. Found at 2 is going to be 0, and then we're going to have a counter as well, and we're going to set that to 0. Okay. We're then just going to dump out on the screen what we've retrieved from the file. So locate, comma 10, print, complete string from file, and we will do a pen 5 print base string dollar, and then turn the pen back again, and then we'll just shove in a quick wait key because I want us to pause as we go through each step on this. Right, save that quickly, run the program, option 2, there's the string which we've retrieved from the file. All 58 characters, there it is in its completeness. So now we can start to do some magical extraction. And to do that, we're going to kick off with a do loop, and let's get going. So we need to set found at 2 will equal Instr because we're going to look for the first comma, okay? And we're going to look in base string for a comma, and we're going to start at found at 1, okay? So what's happening here is the Instr command is going to dive into base string, look for a comma at found at 1, and found at 1 the first time through this loop is going to be 0. It's going to be 0. So we're starting at position 0, looking for a comma, and where we find that comma, we're going to dump that value into found at 2. Okay? Now, something you need to know about Instr is if it can't find the string you're looking for, it returns a 0. So if it returns a 0, we can use that. And in this instance, we're going to use that to end the program because we've got to the end of our string, we've done all the work we need to do, let's get out of here. So, quick comment here, Rem, if we cannot find a separator, end the program. So if found at 2 equals 0, end if. There we go, quite straightforward. Now, what I'm going to do is to explain in a little bit more detail what found at 1 and found at 2 do as the program, as this loop iterates each time. We're going to put some debug statements in so you can see those values. It's better than me trying to explain it each time round. So if you can see the values changing on the screen, you'll hopefully understand what they're doing. So rem debug code. Okay, quick and dirty programming. So locate 0, 14, print found at 1, colon space, semicolon, found at 1. So what I'm just doing is dumping the values of found at 1 and found at 2 to the screen. Okay, and then we'll do print found at, oh no, found, I want these to be in capital letters because that's how they are defined in the program. Found at 2, space, and found at 2. Brilliant. Okay, we'll do that like that. Will give us a bit of debug code and show each time round where we're finding the location of the commas. Now, with that done, what I want to say is if count equals 0. So if this is the first time through our loop, I need to set a value called length. And I've just abbreviated this down to LGTH because I can't use length because that's a defined word within AMOS. So LGTH is going to equal, brackets, found at 2 minus found at 1 minus 1. Excuse me. Else, it's not the first time through the loop. We can set LGTH just to simply equal found at 2 minus found at 1. There we go, okay? Because when I do the extraction of the string, I need to know how many characters I'm extracting. And I need to get that length of characters. It's basically the space that's occupied between each comma that has been found by the Instr command. So I define that through. The first time through, it's always going to be -1 because otherwise I'll have 1 space extra, which I don't need. You'll see it happening on the screen. It really is good fun. Another debug code bit in here. I'm going to locate 0, 16, print LGTH, code space, and I need to print LGTH, and then I need to do that. So we're going to print the length that way, so you can see that calculation happening. Right, next up, for a bit of housekeeping, I need to do locate 0, 18 plus count. Losing the ability to type now, need another mouthful of tea. This purely is housekeeping because each string that I extract, each value I extract, I just want to print it down the screen. Okay, and then I need to increment the value of count each time I go through the loop. Right, now we're going to see some magic. Let's print what we've extracted. So print extracted string. I'll put count in there. You'll see all this working in a minute. Space is, colon and that, semicolon, and then I need to do pen 5, print. Okay, here we go. We're using $, base string. So we're looking at mid string. We're using base string in the mid string command, comma. Where's it going to start? It's going to start at found at 1, and it's going to extract the length which we've already calculated up above. That's how many characters it will extract. Then we'll change the pen color back. Type mismatch error, print mid-string, base string, string. I've left out the string. Naughty yawning angel. There we go. Okay. Now, once I've extracted that and printed it, I now need to tell the program that found at 1 now equals found at 2. Found at 2 plus 1. We'll do a wait key, and that should be us done. So let's go through what's going to happen here. We start off, the value of found at 2 will be where it finds the comma first time through the loop, yeah? We start off looking at position 0 for a comma in base string, and wherever we find that, we dump that into found at 2. We've got some debug code. We'll print out the values of found at 1 and found at 2. We then define the length of the characters we're going to extract. If it's the first time through, LGTH is found at 2 minus found at 1 minus 1. Otherwise, it's just found at 2 minus found at 1. We've got some more debug code in there to print out the length. We increment the position where we're going to print our values. We increment our counter, that's very important. Then we extract the string, and we use the mid $ command to extract our string from base string. So we go into base string, we're going to start at where found at 1 is, and then we're going to extract the number of characters as calculated in the LGTH instructions up above, dump that to the screen. Then we're going to reset found at 1 will be at found at 2 plus 1. Don't forget, found at 2 will have the value of where the comma is. We need to set it to plus 1, so it moves it along another character, and it will start searching from there. This is all good fun. Let's run this and see what happens. Okay, option 2. There's our string. That's the whole string. So what I've got here is found at 1 is at 0, found at 2, so it found the comma at position 4, and the length was 3 characters, and it's extracted 3 characters, and we've got the word dog there. So let's try for my holiday, and it's done it. Look at that. So found at 1 is now position 5. Don't forget it was found at 2 plus 1. So 4 plus 1 is 5. There's our 5. The next one will be at 15 characters, and it's extracted 10 characters, which is for my holiday. Let's go again. A cat named George. There it is. Found at 1 position 16. Found at 2 position 34. 18 characters, which we know is right. A cat named George has come out. String 4 is just the word 7, which is 5 characters. String 5, Pac-Man, is 6 characters. It's got that, it's done that right. 47 minus 41 is 6. And the 6th string, Happy Fish, 10 characters long. Found at 1 is 48. Found at 2 is 58. 58 minus 48 is 10. It's extracted 10 characters. There it is. That all works. A treat. Brilliant. But will this work for an externally created CSV file? Right, we'll quickly create a CSV file out of this spreadsheet. So let's put some values in these cells. So we'll have word 1, we'll have something 2, more 3. You can put anything you like in these, but I'm just doing this to prove a point, show you that this works, and we'll have result 5 there. Please note I've left an extra column at the end. The cell is empty because it will generate a comma to go at the end. I'm just going to lose these extra cells that I don't need. Then we'll quickly export that to a CSV file, and we'll call this test CSV1, and we'll just export that, and that is done. So just to prove that that has worked, so I've got my CSV file here. So this is a CSV document, but what I'm going to do is open this into a text editor, and we can quite clearly see we've got the entries from the cell with commas in between them. So we've got content, we've got commas. We can now get this over to the Amiga and run it through the program. Here we are in TextEdit again, and this is the test CSV1 file I created from the spreadsheet on my Mac. So here it is. We've got the values, they're separated by commas. Look at that, they're all here. So the theory is now I should be able to take this CSV file, and load it into that AMOS program, and it should separate out all these fields based on where the commas are, separate them out nicely and display them back to the screen. So let's crack on and do that now. Right, very quickly then, back into our program code. Let's just quickly comment out that line. Let's open our, for random one, let's do our test CSV1 file. Okay, so that's what we're going to load into the program now. So I've just commented this line out. So they're putting that little apostrophe there, comments out the line. What I need to do, I'm only going to use our advanced procedure here. And what I need to do is just quickly comment out that, because I need to define fields 1, and this is going to be 38 characters now as base string $. Okay, so I've commented out our definition of 58 characters for base string. Our new string in the CSV file is 38 characters, and I can prove that by going into, there's our test CSV1, and here we are. It is, if I look at column 38 there, that's where we are, column 38, we are 38 characters long there. Great. Okay, so we're reading from the new file. We've redefined the length of field 1. All I need to know is the total length of that total string. So let's run the program and see what happens. We're going to option 2. There's our complete string, word 1, something 2, more 3, value 4, and result 5. Let's go. Word 1, something 2, more 3, value 4, result 5. Look at that, it works. That is brilliant, and all I've had to do is change 2 lines of code to bring in an external CSV file. The mechanics of this program works, and I'm well happy with that. Job done, result. And that is it for another video. Thank you ever so much for watching. Don't forget, the source code for this program can be downloaded from my website. The link is here. Also, if you wish to support my work and support these videos that I do, I have a Ko-fi account. The details for that are here. I can be contacted on various social media channels. Once again, there's a list scrolling up the screen now, or you can just leave some comments down below. Let me know what you thought of this video, or if you have any topics you'd like me to cover for future videos. I love to hear from you. And to everyone who's given me feedback so far, I really appreciate it, and thanks for your time. Right, well, that's it. More AMOS videos to come, so subscribe to my channel. Make sure you don't miss them. I've got a lot of stuff in the pipeline and some exciting things to come, also based on previous videos that I've already done. So the journey ahead looks very exciting indeed. Thanks once again, look after yourselves, and whatever you do, keep it retro.